All right. So the last thing that we got to talk about with similar triangles. So we've already learned about what makes a similar triangle, as well as how we determine if two triangles are similar. All right. Now we're going to talk about one phenomenon that comes with similar triangles called the side splitter theorem. And the reason that I had you guys do this type of triangle for warm-up, again, is because side splitter theorem exclusively involves triangles that look like that. All right, so I wanted to make sure that you guys could recognize how to figure out the different pieces of it just on a similarity aspect. Now, just to review, who remembers one postulate that can be used for similarity? So there are three. All right, so just like how there's congruency postulates, so like angle, side, angle, 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 side, hypotenuse, leg, etc., etc. What are the three postulates that we can use? Angle, angle is one of them. And what does that mean? Two angles or all three have to be congruent. All right. And remember, as long as two are congruent, it's implied that the third's already congruent because of the third angle. What's another one? Someone else.
Is SSS another one?
Right, side, side, side. What does that mean? Anyone? So side, side, side is one of them, but what does that mean? Not all sides are congruent. That's congruency. So remember, in similarity, not all sides, the sides are not going to be congruent because similarity means same shape and not same size. However, the sides are what to each other? We literally just did for warm-up. Say it again. No. But it does start with a P. Proportional. Thank you. So the sides are proportional, meaning if you set up fractions with all the corresponding sides and you simplify them, they should all be the exact same thing. In other words, if you found the scale factor should be the same for all three sides. Remember dilation, stuff like that. What's the last one? There's one more. What is it? Look back at your notes if you don't remember. We talked about it. What's the last similarity postulate? We already got angle, angle. Side, angle, side. Good. So side, angle, side, which means two sides that are proportional and the angle in between them is congruent. All right. Okay. So side splitter theorem. Now, what side splitter theorem typically it shows if lines are drawn parallel to a given side in a triangle, how it will divide the other two sides. All right. So again, focusing on triangles that exclusively look like this. So first things first, it says that triangle ADE and points BC lie on AD, such that AE and BC are parallel to DE. All right. So it's saying that BC is parallel to DE, which they gave us the little arrow tick marks to show that they're parallel. Now, they want to say that they want us to justify that angle ABC is similar to angle DEE. So if we were looking at this picture, all right, have they already marked some sides for us that we can test proportions? Meaning, have they given us side lengths? No. So postulates side, 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 and side, angle, side are probably out because we don't have enough information for those. However, that leaves us with which one? What's the only other postulate left, guys? Come on. So side, side, side's out, side, angle, side is out. What's the only one that's left? Angle, angle. All right. So we're probably going to have to show that these two triangles are similar by angle. All right. Now, for justification purposes, here's the small triangle. Here's the big one. So those are the two triangles we're messing with. Now, the angles are actually pretty easy to show that they're congruent. We only need two of them, but we can actually show all three. So someone raise their hand, look at it for a second, and see if you can tell me one set of congruent angles. And then you have to tell me why. So one set of congruent angles. Because all three of those angles we can show are congruent, but you need to be able to tell me why. So BCA, so this angle right here, what's it congruent to? DEA. Why? What's their relationship? Because they are congruent. BCA is congruent to angle DEA. Why? Can anyone tell me why? I'll give you a hint. It has something to do with the parallel lines. So one of those parallel line angle theorems that we talked about in Unit 2A. What relationship do those two angles have? And we also talked about this last week.
Same side.
Kind of. They're not same side. The same side is supplementary. We're talking congruent. But you're on the right track. So, parallel line theorems, what are the ones that make congruent angles? Remember some parallel line theorems that make congruent angles. What are they called? I told you need to know those names. Okay, everyone has their journals out, right? Go back into your journals, look at where the parallel line theorem is. It's 2.3. Tell me which one gives you congruent angles. On the shelf over there. So I want all the theorems that tell me congruent angles of parallel lines. There are 4 of them. So it's 2.3. Tell me what they're called. So can someone tell me what one of them is called? Oh, and
Corresponding angles.
okay, corresponding is one. What's another one? Vertical. What's another one? There's 2 more. Alternate interior. What's the last one? Alternate exterior. So out of those 4, what's the relationship here? Nope. Nope. Corresponding why? What makes those corresponding? So if it helps, guys, extend these lines. Now you can see clearly where the transversal are, or is. So why are those corresponding angles? What's true about corresponding? This is flat out review from your last unit. Come on. Someone besides Owen, he's carrying y'all. And Ralph. So why are those two angles corresponding?
Obviously go along.
Well, they're congruent. What do you mean by going along with each other?
They're like vertical, but they don't ever like intersect.
Well, they're not vertical. What I tell you guys corresponding means, whether you're talking about corresponding sides, corresponding angles, whatever. What I tell you that means. That they're where? They're always going to be in the blank blank. They're going to be in the same blank. Starts with an S. Four-letter word.
Sides.
Nope. They're going to be the same. Starts with an S, ends with a T. Four-letter word. And they call a dog this name. Starts with an S, ends with a T. Spot. It's in the same spot. All right, that's why they're corresponding. They're in the same spot. If you look at these two parallel lines, all right, if I move this angle down, it'll be the exact same spot. It's just a translation. You gotta know these guys. So those two angles are congruent because they're corresponding. Yes. Yeah. Someone else who has not talked yet. Another set. So we already got one pair. What's another set? Ralph, you already said it? Someone else besides Ralph. Ralph. He kind of already gave it to you. BAC and? Right. BAC is congruent to DAE. So this angle right here, why? So first off, why did I only mark one angle? Why did I only mark one angle? This one right here. They're the exact same angle. So, someone has not spoken yet today. Why can we say that those two angles are congruent? We talked about this when we talked about proofs. What property tells us that that angle is congruent to itself? I heard it. Who said it? It's reflexive. The reflexive property, meaning it's in the exact same spot. Not just like, shifted down. It's the exact angle, exact same position. So this is the reflexive property. Now, I know that that's enough information to say angle, angle, but just so we're good on this, the last two sets of angles are right here. So that'll be angle ABC is congruent to angle ADE. Why? Why are those two angles congruent? What's their relationship? We already talked about it. They're corresponding. So guys, this is true for any triangle that looks like that. It's going to have two sets of corresponding angles, which makes them congruent, and they're most likely going to have one reflexive. All right. So I can say that triangle ABC is similar to triangle ADE by angle. Now, I told you guys that because, like, why we took the time to go through this. One, it's vocabulary. You got to know your vocabulary. That's why I give you all that stuff to go in your glossary. All this stuff's on there. All right. Two, if you can't tell me what it's called, I know you can recognize that they're congruent. But if you can't tell me why, that's like half of math right there. All right. A lot of times, especially when it comes to these, I don't care about the what. I care about the why. It's okay if you can recognize that they're congruent, but if you can't tell me why, then do you really understand it? All right. Now that we know that we're similar, that means that we should know that the sides are proportional, all the angles are congruent. So now we can do all those different similarity properties. So they then tell us that AB is 6, AD is 10, AC is 9. And we want to solve in set proportion to find the length of AE and find the length of CE. So first things first, before I do anything, I'm going to label on my triangle everything that they just gave me. So AB is 6, AD is 10, AC is 9. And they want us to find the length of AE. So let's call that X. And CE, let's call that Y. So, which side length is going to be the easiest to find first, X or Y? I wouldn't say Y. I would say X. Why would I say X? Right, because we already have a full side and a piece of the other triangle. We have the two corresponding sides. So, Y is not a corresponding side to anything. It's just a piece of one of the bigger sides. Whereas X is actually a corresponding side. It's corresponding to the 9. All right. So, we're going to set up our first proportion with what we already have. So, what two sets or what pair of sides that are corresponding do I have that I can set up a proportion for, where both sides are known? What are those two sides? So what is the only set of corresponding sides that I know both of the sides to, so I can set up my proportion? AB and AD. All right. So these two sides I know. So that's going to be my first proportion. Now, it doesn't matter which way you set it up, as long as whatever we set up for the first proportion, we keep it consistent with the second. All right. So I'm just going to continue doing big over small. So I'm going to do 10 over 6. And I want to set it equal to my second proportion. So that's where I'm going to do AE and AC. So the first proportion is AB over AD. Nope, backwards, sorry. AD over AB. I'm going to set it equal to what side over what? So if I use the big triangle first on top, that means for the next one, I got to use what? The big triangle on top. So which side length is that? What's the only other big side length marked? Come on, guys. You're killing me. What's the only other side length mark? I don't care if you're wrong. Just say it. AE. Thank you. If you're wrong, it's okay to be wrong. That's the part of math. But you got to actually give me something to work with. You just stay silent. I have no clue where the heck your head's at. Give me something. You could be as wrong as can be. I don't care. That's the whole point. All right? We learn from our mistakes. If you don't make the mistakes, how the heck can you learn? All right? And it's going to be over AC. So, based off of that, how do I set up my second proportion? Using the side lengths now. What's the placeholder for AE?
X.
X over what? 9. So, right there is my proportion. Now, who remembers how I solve it? Cross multiply. So I'm going to do 9 times 10 is equal to 6 times x. So what's 9 times 10? 90. It's equal to 6x. What's the only thing I got to do to solve? Divide by 6. What's 90 divided by 6? I have calculators, use them.
15.
Right. So x is equal to 15. So that's also what AE, not AE, AC. Nope, it's AE. Good Lord. So AE is equal to 15. So x is 15. Now, how can I use that little tidbit of information to find what CE is or Y? Subtract what? Right. So Y is going to be equal to 15 minus 9 because it's the other little piece, which is what?
6.
So CE is equal to 6. Does everyone understand how you set up the proportion to find a missing side? All right. Now, what they want us to do now is to set up these other proportions. So first off, this first proportion, it's AB over BD. However, do we know what BD is yet on this triangle? No, but can we easily find it? Yeah. What is it? Y. 10 minus 6. So BD's 4. So what's my proportion? 6 over 4. What does it simplify down to?
3 over 2.
3 halves. All right. What about the other one? So AC over CE. So what's my proportion?
9.
9 over 6. What does it simplify down to?
3 over 2.
3 over 2. Now, so what we did is we took the two pieces that make up AD and the two pieces that make up AE and we made them as proportions. So what's true about those ratios? Someone who has not talked yet today, what do you notice about those two ratios when we simplify them? They're the same. So the proportions are the same. Now, what we just did with part C, that's actually side splitter theorem. All right. So, what side splitter theorem actually is if a line is drawn parallel to any side of a triangle and intersects the other two sides, we can divide them proportionally. Meaning that if we do AB over BD, it'll be the exact same as AC over CE. So, in other words, you take the two pieces of one side, put it over each other, and you take the two pieces of the other side, put them over to each other. And as long as you keep it consistent, so in other words, top piece with top piece, bottom piece with bottom piece, they will be the same proportion. All right. Now, I don't really want to go about proving the side splitter theorem because it's going to go over your head. So we're going to skip exercise 2 and move on to actually putting it into action. So let's look at exercise 3. Now, be careful with these because instead of having it split into 2 triangles, it's now split into 3 triangles. All right, but side splitter still applies. So in the following diagram, RU is parallel to SV, which is also parallel to TW. So these 3 sides right here, I'm going to mark as parallel. Now, it then says that RS is 15, VW is 6, TZ is 25, and WZ is 15. And they want us to find ST, so I'll call that X, and UV, so I'll call that Y. Now, I would also like to point out where all the triangles are. So there's the smallest one. There's the medium one. And here's the biggest one. Let me just move these so they're out of the way. Okay. 25, 6. So you need to know where all of those triangles are. Now, let's solve for X first. All right. So if I'm solving for X, which two triangles am I exclusively working with? So am I working with the blue and the green and the yellow and the blue? What do you think? I would say yellow and green. All right. Because for side splitter theorem to work, you have to have 2 full triangles. All right. Now, remember, side splitter theorem, so ignore this part. All right. You're going to do 2 pieces of one side over 2 pieces of the other side. So, that being said, how would I set up my first proportion? So I'm using these 2 sides. How would I set up one proportion? So 15 over 6. I'm going to set it equal to what? Someone else. Do what? Not quite. Make sure you keep the same sides together. 25 over x. So 25 and 15 are both the top, so I got to use them on top. X and 6 are both the bottom part, so I got to use them on the bottom. Make sure you keep that consistent. Then I can cross multiply. So I get 15x is equal to 25 times 6. What's 25 times 6? 150. So 15x is equal to 150. What do I have to do next? Divide by 15. X is equal to what? 10. So that is what ST is equal to. Now, I then need to find UV. So, remember, I need two sides that make up a full triangle. So think about this carefully. So, in reality, all right, I'm using the blue and the green triangles. All right, but I am not using these two sides and these two sides. All right, because I need to have the actual tip of the triangle in there. So, in reality, what do I need to do for the green triangle in order to get two sides? In order to include point Z, which is the tip. So in other words, how do I make this look like that? So I need to include this point right here. I need to include that point and make sure it's in both my triangles when I side split. So we know we're going to have to use the 15 and the Y, but which number should I use for the other? Or do I need to do something to do those numbers to get the other? Not subtract, but you're on the right track. Think the opposite of that. Add what? What do you think I'm going to add? Give you a hint, it's already circled. You're going to add 6 and 15 to get the full side of the green. And I'm going to add what? The 10 and 25 to get the full side of the other side of the green. So 6 plus 15, that's 21. 25 plus 10, that's 35. So I had to add up those two sides because in order for side squared to work, I gotta have two sides that at least come together to make a point. So I have to use all of the green triangle. So if you notice, we used all of the yellow triangle for the first one and then the bottom half of the green. Now I gotta use all of the green for the second one and the bottom half of the blue. All right, does that make sense? So I had to add these together in order to give me all of the green. So that's typically how side splitter works. You use all of one and part of the other. Okay, so we can't just use a part and a part. It's all of one. It's usually the smaller triangle. It's all of the smaller triangle, part of the bigger one. All right. So that being said, how do I set my proportion to solve for y? So one proportion, how do I solve? I got 35 over 15 that comes from the top side. And it's going to be equal to what? Someone else. $21 over not x, but y. Good. And then I can cross multiply. So I got 35y is equal to 21 times 15. What's 21 times 15? 315. So I got 35y is equal to 315. Divide both sides by 35. What's y equal? It's what? 63. Good. So 63 is equal to y, which is also the length of UV. So guys, these are not necessarily hard. The math is not hard. The hard part is figuring out which numbers you gotta use and how to set up those proportions. But then once you do that, it's just a simple cross multiply and then divide by the other number. All right. The math's not hard. The hard part is figuring out how to set it up. So you got to be really careful. Just remember when it comes to side splitter, it's always all of the small triangle over part of the big. That's how you set up the proportion for both. It's all of the small over part of the big. So it's going to be all of the small side over part of the big side. And it's the part that you didn't use. All right. So let's try another one. So in a right triangle, ADE is shown below. Leg AE has been partitioned into lengths of 2, 3, and 5. Now, the line segments drawn parallel to ED. So that means all of these side lengths right here are parallel. It says that AD is 30. So AD is 30. And they want us to find all of these other lengths. So let's call this X, Y, and Z. Now, to give us a hand, we can actually, this is a little bit different first. We don't actually go, yes, yeah. So, we don't actually go straight into side splitter. We actually got to use something that we did earlier with our warm-up this morning in order to get one side that we can then do side splitter from. All right, so we got to use just similar triangles first. So, first off, what's the length of AE? Because we need that. The length of AE is what? 10. So, here's my question. Here's all your triangles again. So there's the small one, your medium one, and your big one. So before I do side splitter theorem, I'm just doing some similarity stuff. Which two triangles do I have enough information for just to set up a similarity proportion? So a corresponding side over a corresponding side equal to another set of corresponding sides over each other. So which two triangles do you think I'm going to use? Blue and yellow. So we're going to use the blue, so the big, and then the little tiny yellow. Because if you notice, the yellow, we got one given side, and then the other one, we got enough information from the blue triangle to set up a congruent proportion. All right? So I want to do that first. So I have 30 over 10. All right? Well, actually, let's do 30 over x. It'll be equal to what? 10 over what? What's the corresponding side of 10 on the yellow triangle? 2. Guys, trust your gut. You're probably right. Cross multiply, I get 10x. 30 times 2 is 60. Divide both sides by 10. What's x equal to? 6. So x is equal to 6. Now, with that, I got enough information to use side splitter theorem to find the other two. So based off of the information I have next, what two triangles am I using? Not green and blue. So we're using side splitter theorem. So remember, I want all of the small, part of the big. Yellow and green. Good. So I'm using yellow and green next. So I'm solving for y. All right. So how would I set up my proportions? So remember, all of the small, part of the big. So how would I set up one of the proportions? Not 30. Remember, we're using yellow and green. 6 over y. So 6 over y is one of them. And it's going to be equal to what? Nope. Green and yellow. Green and yellow. Backwards. No. You're right. You're right. So that's why I recommend, coloring your triangles or whatever, just so you know which triangles you're dealing with, because it can get confusing. Okay. Whether it's that, like, you use different type of lines, like a squiggle line, a straight line, and I don't know, a dotted or whatever, or you use colors. That will help you distinguish which triangles you're talking about. So I'm going to cross multiply. I get 2y is equal to 18. Divide by 2. What's y equal to? 9. So y is equal to 9. So lastly, I can solve for z. So I got x and I got y. So remember, I need all the small and part of the big. So there's a couple of options you can use for this. It doesn't matter. Which two do you want to go with next? What triangles? What'd you say? Green and blue. Okay, we can use green and blue. All right. So, problem is with green, what do I have to do to the sides? Add them. So, for the green, I got to add the 6 and the 9, and I get what? 15. And on the other side, I got to add the 2 and the 3, which is 5. So remember, if you do all the small part of the big, you got to make sure that if the small is broken up into 2 pieces, you got to add those 2 pieces. So how would I set my proportion? I would do 15 over 30. And then 5 over what? 10. Oh, whoops. Nope. So it'd be 15 over z, 5 over 5. All right. Cross multiply. I get 5z is equal to 75. So if I divide both sides by 5, what's z equal to? 15. So in reality, since this piece and this piece is 15, this piece and this piece is 5, these 2 points right here are midpoints. So what would this segment be called right here? Just review. What would that segment be called if it's made up of the 2 midpoints of a side? Talked about this back in the last unit.
Is it, oh, no, it's not the mid segment.
No, it is. It is. Okay. It is the mid segment. Since it's formed by the 2 midpoints, because we got equal distance on both sides, that side length is actually the mid segment. But that was just a fun little review part. Doesn't really apply to what we're doing right now. So does everyone understand how to set up these proportions? Again, use color to your advantage or use different markings to your advantage. All right, because again, it gets confusing very, very quick. Now, the last thing you need to know about side splitter theorem, and we'll do this quickly, is that a line or segment that divides 2 sides into the triangle proportionally, then it must be parallel to the third side. So it's pretty much just the opposite of what we already did. All right, so what they said is that if you have 2 parallel sides, if you split the sides, they're proportional. So in other words, if the sides are proportional, then those 2 sides have to be parallel. So very quickly. All right, we need to verify that AB over BC is equal to AD over DE. So I would do 10 over 8 is equal to 15 over 12. So if I simplify 10 over 8, what is that? 10 over 8 simplified. What is it?
5 over 4.
5 over 4. 15 over 12, what is that?
5 over 4.
5 over 4. So they're the same. So because of that, we can conclude that side BD is parallel to side CE because the side splitter theorem worked. All right. Now, the rest of this is just talking about how you can then find common ratios to prove similarity, all that loveliness. All right. So, any questions on the side splitter theorem? All right. So your classwork dash homework, and you really only got like 10 minutes left of class, but there is a new Delta math that's pretty short, but it covers stuff like this. All right. I also threw in some stuff that looks like the warm up from today just to kind of get you thinking about it. So you can go ahead and get started on your journals as well. They'll be due